Testing. 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 Do we have volume? Is there volume? Unsure. Not yet confirmed. Volume. Volumen. Come on. Come on. Let me try refreshing this. Okay, maybe we have volume here. Testing. Okay, I think I'm getting it. Alrighty. Happy Thursday. Welcome to another HoopPost stream. We're doing a little bit of coding today. We're going to be continuing to work on the TubeGPT project. So the TubeGPT project is a little project that we've been working on this week for using these AI tools to make a little assistant for YouTube creation. You can find all of this code on my GitHub. So you could, if you go to HoopPo, which is my GitHub, and then you can actually go here to the contribution activity. This is for everyone's GitHub, and you can see what people have been contributing to. And you can see here that the latest things I've been contributing to is this TubeGPT repo. So yeah, MIT license, so feel free to use it. And whatever you want to do with it, go for it. So today I kind of wanted to add new functionality to TubeGPT, and the functionality I want to add is based around the segment anything model. So the segment anything model, let me pull this up for you guys. Transformers, Facebook, Sam. That's not all what I want. All right. Hugging Face. So Hugging Face is kind of like a model repository. It's a place where people store models and data sets and make them available. And on there, Facebook, the company, has a repo, kind of, or an organization. I don't know exactly what it's called, but they have a variety of different models. And one of the models that they have available is exactly this one, Sam VIT. And they have it in 3 different sizes. They have Sam VIT Base, Sam VIT Large, and then Sam VIT Huge. We can probably do all the testing with the smaller one, but basically what Segment Anything does, it's a foundational vision model that will segment any image, and you can segment it with different things. So you can segment it with either points or a box or a text, and text is really the interesting one that we want, which means that you can describe with text something, and then the Segment Anything model will segment that out. So we're going to be using the transformers, which is Hugging Face, in order to load this Segment Anything model. And the purpose of this is I want to basically extract foregrounds and backgrounds and images such that we can create thumbnails, right? So a big part of this TubeGPT repo is the automatic creation of thumbnails. And one of the pieces of that is you need to basically have this foreground, background situation. So if we actually go into YouTube, right, you can look at here, I'm kind of scrolling, and you see the thumbnails that you have here, right? And most thumbnails have kind of text, right? They have this kind of like large text here. They usually have a background, and then they usually have a couple foreground elements. So like, for example, here, Mr. P Solver's video on Python and NumPy, you see how there's a kind of a foreground of a Python logo, a foreground of this GPU. Maybe here you have a foreground, a kind of a human in the foreground is also very common. So being able to take an image and then take out the human or maybe a specific item within the image is important for thumbnail creation. So that's largely what we're going to be trying to do. All right, so in order to do that, I went ahead and added let me close this real quick. I pip installed transformers, which is basically the Hugging Face. Transformers. All right, cleared. Then we're going to restart our VS Code. And you can see that when we restart our VS Code, make sure here in the bottom corner that you're using the right Python environment. I have a Python environment called TubeGPT. And you can use your own Python environment by just installing the dependencies here in the requirements.txt file. So you're also going to need a key for Hugging Face, a key that identifies you as a specific person, so you can download the models and use them as is. So you can see here, transformers, we're importing SAM model and SAM processor. Unfortunately, those look white, right? So you don't really want to see this white color. What that means is that VS Code does not know what this is. It doesn't know that SAM model is part of transformers. So, all right, let's scroll down. I made a little function here called segment image, and we're going to need to call this function from one of our grad.io front end kind of widgets. So let's scroll down to our front end. We have a couple different things here. We have kind of the, let me actually run this so you guys can see it. Why is my shortcut not working? All right, there we go. I have shortcuts for automatically running and debugging the program. Cannot import name SAM model from transformers. Okay, so you see it's not getting this. So right here, from transformers import SAM model, SAM processor, that does not seem to be available. So we're going to comment that out, and we're just going to say import transformers. And you see the problem here is that, let me first close out of this. So you see, right now, when I hit save, it's auto-deleting that import because I have a specific setting that is no good. I have this setting here, format on type, format on save. Yeah, I don't want this format on save at all. Editor, code actions on save. Let's get rid of this. And let's get rid of this. Let's get rid of this too. Control W. Let's see if I type it now from transformers or import transformers. If I hit save, it's still getting deleted. Really annoying. So let's go over here. Let's actually use it. Transformers. Set Hugging Face API key. We'll just leave that. This is actually like incorrect, but I just want it to not delete my import at the very top. All right, there we go. Let's save. Let's run it. My hotkeys are not working. Let me try closing VS Code here and rerunning it. See if I get something better. Still not working. All right, let me see. Maybe it's the profile here. Profiles. Let's go to Ook. Very annoying. I'm going to have to type it in manually. All right, we're running and our app is working, so we can refresh here and we have a local browser, and you can see here is our little app. So we have a couple different tabs here. We have text, thumbnail, Notion, and keys, and we're going to want to add this functionality here to the thumbnail. So maybe we're going to add something here. So similar to how we have generate foreground. So this uses OpenAI's image API to generate images, and you can kind of put whatever you want in here. Right, there we go. There's a little boot pick. And then this uses the replicate, which is similar to Hugging Face, but kind of more of a lesser known startup. And this will create a mask, so you can mask out the foreground. So I want an additional kind of tool here that allows you to use the segment anything. So let's go ahead and scroll to that area. Here we go. GR row, thumbnail over here. And then we have our row with the foreground mask. And then right here. So we're going to basically copy paste this and this. Actually, more specifically, this. And we're going to put it here. And we're going to call this foreground image. Let's call it GR Sam image. And here we're going to call it Sam image. It's going to be an RGB image. Actually, maybe let's call it a Sam mask. This is going to be a grayscale image. Generate foreground button. Let's call this use. We'll call it Sam. Sam for segment anything. Use Sam. Then we're gonna have a prompt. Here we're gonna put Sam prompt. Show label false. And we'll get rid of this value. Just don't need any value there. Generate foreground. GPT image. Let's change the name of these. So here the button is going to be this one. Or no, it's not going to be that. It's going to be this. This is going to be that. Nope, this is not going to be that. This is going to be GR Sam text box. We're going to put it there. Okay, so now if we refresh and rerun, come here, refresh, thumbnail. All right, there we go. Now we have our little Sam widget, I guess. So let's go into the actual function that we're going to call, and we're not going to call GPT image here. What we're going to be calling is the function that we made up at the top. So I think we call it segment image. And right now we're giving it the text box and the image that we're putting here, or the output should go to this image. But it's also going to need the image that comes out of the foreground or maybe the background. I don't know exactly what we want to segment. Let's segment the foreground image here. So we'll do GR foreground image, and then here where we actually GR Sam text box will also pass the image. So the segment image function is going to receive the text and then the image. So let's go here. It's going to receive the text and then the image. And let's not use the VIT large model right now. Let's just use the VIT base. Okay. Model card, files, hosted inference API, use in transformers. All right, we need auto processor, auto model for mask generation. I think these are the copies that we want, so let's go ahead and put that up there. So we go up here, put that there. Auto model for mask generation does not seem to be an import, so let's get rid of that. Oh my god, this auto delete is so annoying. Let's go down, come to here. Let's get rid of the debug terminal. Segment anything, here we go. We're gonna say processor equals auto processor from pre-trained encoder with the Hugging Face API key. And let's get rid of this. We'll say processor, or we'll call it encoder. And let's put a breakpoint right here. Let's see what we got when we actually run this. Let's see if we can actually load this model or not. Blah, blah, blah. Okay, because really this segment anything model, there's a couple different models here. You have the image encoder, which actually turns your image into an embedding, and then you have a prompt encoder and a mask decoder. So we want the image encoder, the prompt encoder, and the mask decoder. And the prompt encoder, specifically, we want to pass it text. So you see here, I'm kind of scrolling in, scrolling through the images here. From transformers import pipeline, maybe this is what we should be doing. I don't know, there seems to be a lot of different ways of doing stuff here, so we'll see. All right, let's go to our thumbnail and let's click this use SAM, and it should open up a breakpoint. It's not opening up anything. Okay, what's going on? So draw text, resize over here. Let's put a breakpoint right there. Let's go back down here. When we click the Generate SAM text box button, so we had the wrong button there. So GRSAM button.click. Kill it, rerun it, refresh, go to thumbnail, hit the button, and there we go. All right, text is blank, image is none, and encoder is the VIT base. Let's just see if we go one over. Error, key error, Hugging Face API key. So we're not setting the Hugging Face API key. So we need to go down here where we have our keys, and let's go ahead and add the, not the Discord key, but the Hugging Face. Hugging Face API key text box. And all we have to do is just type that in, and then Copilot will fill out the rest, right? So we basically just let Copilot fill out the rest. And you see how it's basically matching what we did up here. And we don't have to type any of this. We don't have to think about it. We just let Hugging Face do all the work. Or not Hugging Face, let Copilot do all the work. So let's refresh. Let's go back to the thumbnail. Let's click our Use SAM button again. And now we're back here. Now let's see if we get it. All right, here we go. None type object has no attribute from pre-trained. Okay, so this auto processor here, generic processor class that is instantiated to one of the processors. So it doesn't like this. Okay. So I think that this example here that they're giving us is actually fake news. This prompted mask generation. SAM model, SAM processor. Let's see if we can, let's minimize this a little bit so we get a better looking thing. Let's look at maybe use in transformers. Is this what we want? Read model documentation. Transformers.sam model. So, I mean, it is there. I don't know why it's not finding it. So let's see if we can get it up here. So from transformers import SAM model. let's see. Transformers does not. Transformers Python module does not have model. No module named Transformers, blah, blah, blah. How to add model Transformers, PyTorch Transformers. Am I even installing the right transformers? So maybe here we go. Let's go into the PyPy and then search up transformers. Not transfers, transformers. Transformers. Go here, right? And I'm looking for this. And transformers, and the latest version here is 4.28.1. So I can go to my terminal here, and I can say import transformers. And I can say transformers dot underscore version 4.28.1. Okay, so we are using the latest one here. Transformers import pipeline. Okay, so actually the fact that this example here has the pipeline, and then whenever we were here in the SAM thing, they also give you an example based around this pipeline call, that's kind of making me think that this is the correct way of doing it. So let's go ahead and import that. So let's go back to our thing. From transformers, we're going to import pipeline. Pipeline, let's kill that. Let's go down to our function and let's paste pipeline. I don't know how exactly, like there's nothing here that tells it to use the segment anything model, so I'm curious how it actually knows. Mask generator device equals 0. I think this is the GPU. Points per batch 256. Let's actually go into the documentation for this. Image processor, task, device, model quarks, use auth token. Yeah, I think we're going to need to add that. So let's go ahead and add the use auth token. I'm going to copy that. We're going to delete this. Let's move these quarks like this. I kind of like this style. Points per batch. We'll put that there. All right. So let's see now what we get. Let's see if we actually can get this pipeline to work here. How does it know what to use here? Like, is mass generation literally a reserved keyword for the segment anything model? Let's see. Refresh, thumbnails, use SAM. Unknown task, mask generation. Yeah, so I don't think it actually has it. You have speech recognition, image classification, image segmentation, token classification, translation, zero shot audio classification, zero shot image classification. Very poor documentation on this, to be honest. How do you install this? It might be the case that production-ready API endpoints. I don't want that. Community. Show closed. Update readme. No description. Let's go back to this. The segment anything model. How do you actually get these? Because I don't have these inside transformers. Textual input should also be supported. However, at the time of this writing, it seems to be not supported. Ruh-roh, that's not good. This also doesn't work. You know who might know this? Let's ask our good old friend ChatGPT. Let's clear these conversations. Let's go into GPT-4 and let's say I am trying to import the following Hugging Face models, but these classes do not exist. Why does the Hugging Face documentation tell me that they do exist? It is possible that they're referring to is outdated or incorrect. Okay. Is there additional installation steps for specific Hugging Face models that I am unaware of? Hugging Face demo notebook. Like, this literally doesn't exist. That's the problem, right? When I go here, it doesn't know what those are. Segment anything? Sam? I don't like this. I don't like that it's telling me that it's there, but it's not. Maybe we don't use transformers and we just use the repo as is, you know? Using SAM with prompts. Predictor. These are all like point-based prompts. I haven't seen any text-based prompts. This isn't looking super good, guys. Looks like all of this is borked. Let's see if there's any other Hugging Face. Can I look at models? Models. Sometimes I just feel like Hugging Face is a huge piece of shit. Image segmentation. Sort by most likes. Deter ResNet 50 Panoptic. Segformer B0. Updated 10 days ago. This one seems potentially good. What is this? Fine tune on 80E20K. Hierarchical transformer encoder. Like, am I missing something here? Why do all of these examples pretend that you can just import from transformers, but then you can't actually do that? Oh, this one actually is there. Okay. What are the classes here? So it says they use 80E20K. What does 80E20K have? 80E20K. Overview. Let's see. So these are all the different classes that are available in 80E20K. These are kind of mostly external ones. We got clock, coffee table, fruit. Actually, some of these are pretty good. Okay, let's see. Let's try it out. Because this one actually seems to be working, so let's copy this code here. Let's put it here. Let's paste it. Make it big. We're going to kill the current command. Close that. Feature extractor. These examples are just not even correct. Like, look at this. There is no such thing as a feature extractor. They probably mean the processor. Dude, these examples are hot garbage. I'm going to call it the encoder. Okay, so we import these two image processor, semantic segmentation, load them up. Now you have your URL. We don't actually want that. We want image dot from array, and we're gonna just do the image. Encoder, images, return tensors PT. I think this means that it'll return the PyTorch tensors, because we want to basically take the PyTorch tensors from our encoder and feed it into the model. Let's actually put a little breakpoint here so we can know exactly what's going on. Then we can get rid of this. We're going to actually also need to do use the Hugging Face auth token. We're going to have to add that to our code right here, right? Actually, let's ask ChatGPT. Let's see. Is there a preferred way to set the Hugging Face API token once rather than at every time the from pre-trained is called? Yes, you can set the Hugging Face as an environment variable so you don't have to pass it every time you call from pre-trained. Okay, tell me how to do that. For Linux and Mac OS, you can run the following Hugging Face API key. Okay, so let's actually just do that. So here, let's get rid of this use auth token. And let's go to our set hugging face key. This is a function that we have defined. And then here, rather than using this weird name that we came up with, we'll set it to this exact Hugging Face API key OS environment variable, which is what the Transformers library looks for. All right. So we don't need this. All right, and let's make sure to call it with the image. So let's save. Let's put these breakpoints. Let's put a breakpoint here as well, I guess, and let's run this. So we run this. We go into our grad.io app, into our thumbnail. Let's upload a random image here. Why is this not? What is the difference between this and this? Why does this always happen? Right? I don't know why sometimes you get the drop image or click to upload and sometimes you don't get that. So gr sam image, sam mask. Let's ask GPT. New chat. Why do I sometimes get a grad.io image box that allows me to drag-upload an image, and sometimes it does not allow me to do that? Right? I don't like why can't I upload this image, right? That's what I want to know. GPT has to think about this one. Come on. What's going on? What's going on, GPT? Tell me more. Only one message at a time. Please allow the other responses. Okay. So it's still chewing on the last message. It could be related to the platform or service, your internet connection, blah, blah, blah. Okay. It's none of those. See, I'm looking at this here, and it's almost identical, right? Like this gr mask image is basically exactly the same as the gr sam image, but why is the gr sam image showing up like this? Let's ask Google this exact question. Grad.io image does not allow for upload. Yeah, okay, so ChatGPT does not know what that is, and neither does Google. It's really annoying. but let's just keep going here. Okay, that loads. That loads. See, it paused for a second there. Import error. Segformer for semantic segmentation requires the PyTorch library but was not found in your environment. Okay, so we need to basically install PyTorch manually here. Let's see. This is the original Segformer paper, and you see how we need OpenCV Python, we need Torch Vision, we need a couple different things here. Okay, let's install Torch Vision. Pip install Torch Vision. Torch Vision is PyTorch's like kind of vision package. Let's install that into our It's installing PyTorch 2.0. It's installing cuDNN for CUDA 11. I think that's pretty sure that's the one we have in here. So you can always do NVIDIA SMI and you'll see the CUDA version we have. We have CUDA version 11.8. So that seems fine. Okay. Let's go ahead and put Torch Vision on our requirements list. So requirements. Let's put Torch Vision on there. Let's close out of that. It installed. Let's see if we can actually get it. If we say import PyTorch, or sorry, import Torch, torch.version, torch.cuda.is available. This will tell you if the GPUs are there. Okay, we do have the GPUs. Let's see, import Torch Vision, and that is also good. Okay, so we have all the dependencies that I think we need. So let's go ahead and rerun our little thing here. I'll rerun it. Let's go back to our app, refresh here, go into our thumbnails tab. Still not getting the mask image there. I don't know why, but I guess. Use SAM. We're going to get to this point here. Skip to next line. Skip to next line. Skip to next line. Here's where we get the import. You see, there we go. It downloaded the model. The model's only 15 megabytes, which is actually quite small. And now we have this empty image, so we need to actually have a real image here. So we're going to have to close this out, and we're going to have to upload an image. Okay. So one thing that's different between, for example, this GR-SAM image is that the GR-SAM image is only an output. Right? It's not an input to anything, right? So if you see here, the FG image is an input to this function here, the GR make mask button. But the GR-SAM image is not an input to anything. So that's why I think it doesn't allow us to drop the image here or click to upload. So I think what we're going to have to do here is we're going to have to say GR-SAM image is also an input to segment image, and the segment image returns the GR-SAM image. So basically the return is going to be the input. We're going to be using the same image object to do that. So if we go ahead and refresh, now, yeah, there you go. Now we actually have it. So let's go ahead and upload some random image here. Let's upload this one, for example, and then we'll hit the use SAM button. Go through this step by step. So loading the encoder, getting the image. The image is now an MP array. So this is a 1395 by 707. It's going to go through the encoder. I think it's going to resize it. All right, here we go. Unsupported number of image dimensions 2. Image resize. So it did not like this. Whenever it tried to format this image, it tried to resize it, and it did not like that. So let's close out of that. Let's get rid of this breakpoint. Let's rerun it. Let's refresh here, and we're going to try to do that again, except we're going to stop at the breakpoint, and we're going to see what we get. Let's upload this meme. All right, so we're here. What do we have for our image? You see, this is the problem. The image mode is L, but we actually want an RGB image. So let's close out. Let's go back down here. Here where we have our SAM image, we need to change the image mode to RGB. So L stands for grayscale image in Hugging Face, or not Hugging Face, in Grad.io's image tools, but we want an RGB image. So let's go ahead and rerun that. Refresh. Thumbnail. SAM mask. Pictures. Let's give it this meme. Let's use segment. Now what do we have? Now we have an image that is of type RGB. The size is 994 by 1130. I feel like that should be fine. If we go to the next line, okay, we got it. Let's look at what the encoder actually returns. So the encoder returns an object. This object here called inputs. Come on. Jesus Christ. Okay, we have to look at it through here. So this inputs object has a couple different things here. It has a pixel values, which is a tensor, a float 32 tensor. It's currently being stored on the CPU. And what else do we have here? It's 1 by 3 by 5, 12 by 5, 12. So you can see it's already got the batch dimension. It's ready to be put into the model. So most of these models, they don't just take a single image, they take batches of images, so you have to have a dummy batch dimension. So let's go to the next one here. Cannot process this value as an image. All right, so it ran and then it died somewhere here. Let's go here. I think this is the problem. Model inputs and the output of the model. Let's see what they have in the examples here. So they just have it outputs, and then the outputs, maybe we'll just do that, and then we'll see what we actually get when we look at this outputs object. I don't know what this is at all. So we'll say outputs equals models inputs, and then we'll say outputs, maybe print. We'll save, we'll put a breakpoint right here. And let's see what we get. Let's close out of that. I also don't like, since we're no longer using SAM, let's actually change the name of this here. So here where we have the GR SAM image, let's rename this, and you can hit F2 in VS Code to rename. Let's call it GR segment image. The GR SAM button, let's rename that to GR segment button. And this GR SAM text box, let's rename it to GR segment text box. And we'll call this class, or class name. Let's go ahead and run that. Go into our Grad.io, refresh into the thumbnail tab, into the SAM mask tab. We're going to upload a random image here. What about this meme? Let's upload that meme. Let's click the use SAM, and there we go. So we got our model output. And what is the output here? So the output that this model is giving us, it's giving us logits, right, which are basically the probability distribution over all the different classes that are available. But we don't know what those classes are, right? So we need basically a dictionary, a map that says the first class here is, I don't know, like book or something like that. The second class is dog. So if we actually go to the segformer, hopefully they have an actual, let's look at the documentation. I feel like they should have the dictionary. So any kind of segmentation or image classification, there should be a actual map where you can put in the logits and get the actual names. Decoder head, forward. Here we go. Predicted labels, model.config. This is the dictionary we want. ID2 label, predicted label. Semantic segmenter output. Segformer for semantic segmentation. This is actually the one that we have. Batch size, num labels, height. What does this do? This model, blah, blah, blah. Does it actually give you these masks? Is this what it actually gives you? Let's see if this even exists here, this model.config. So if we're here, right, we're inside, we're breakpointed. So let's do model.config.id2label. Of the predicted label, and let's go ahead and copy the logits.argmax here. And we don't actually have the logits here, so we have to do output.logits.argmax. Output is not defined, it's called outputs. A tensor with 100, 1,000, 19,200 elements cannot be converted to a scalar. Okay, so outputs.logits dot argmax of -1 dot item. Okay, so it's failing here. Okay, so here you have the argmax of the -1 dimension, but actually outputs.logits, let's see what the actual dimensionality of this is. Dot shape. So we don't actually want the last dimension. We want the first dimension. So actually what we want is this, argmax of 1. And if we say the shape of that, now we have our mask, right? And for example, what is 19? So 19 is going to be a specific class. So let's minimize that. If we go into our ID2 label, let's say we put 19 in here. 19 is chair. All right. So this is giving us a mask with the labels. Yeah, let's do this. So we copy this. And we're going to say the predicted mask with class indices. Class mask, we'll call it that. And I do like this little trick that they're doing here, this with torch no grad. So this basically tells PyTorch that you don't care about the gradients here. And this is important because it prevents some extra calculation. So Torch wants to basically keep track of the gradients at all times, right? So that you can do back propagation. But if you're just doing inference, which is what we're doing in this case, right? We're not doing anything with this model. All we're doing is just doing inference. We're not going to train it in any way. So we don't actually care about the gradients. So we can just basically tell PyTorch, hey, I don't actually care about the gradients here. Just calculate this without keeping track of gradients, and it'll be a little bit quicker. It might not be significantly quicker, but you know, anywhere you can get a little bit of speed is good. And let's say class mask. Get the class names with, yep, there you go. Get all the unique classes and their name. Class IDs, torch.unique class mask. And then class names equals that. Okay. And get the mask for each class. Or actually, get the mask for the text class. Class IDs, class names, index text. No, we want this text here. So we want if text in the class names get the index of the class we want. No, we want the model.config.label to ID. Let's get rid of this. Label to ID of text, class ID. Mask is wherever the class mask equals the class ID. Then squeeze numpy into CPU as type uint8 times 255. Sure, that's going to make us a mask. Then we're going to do image from array, and then we're going to return the mask. That seems pretty good to me. Let's go ahead and run this. Let's put a little breakpoint here just so we can see what's going on, and let's run this. Go into our grad.io, hit refresh, go into the thumbnail. We're going to come here. We're going to say chair. We're going to update our image. Let's put in the meme, and let's go ahead and segment. So now we are here, right? So what are all the class names that we found in here? We found wall, floor, cabinet, door, table, curtain, chair, painting, column, cradle. So if text in class names, which it should be, right, we got the mask. And let's see. So that is the chair. That doesn't look very good to me. Let's see. Does that match the picture? No, it doesn't look like anything. Maybe it's encoded? Let's try it with something simpler here. So what happens if we, let's go here, let's use one of the cats. Okay. Then we're going to put this image here. Save image. Save. I'm going to upload it here. And let's see if we can get the cat from this. So we're going to hit segment. Wall, floor, bed, person, animal, blanket, tray. None of these are cats. What do we just say? Animal. So let's come back here. Let's say animal. And let's drag our image there again. All right. Class names, we should have animal in here. Yep. And we have animal. Okay. Hit go. And hit go. Okay, this is straight up garbage. That is not a good mask at all. All right, let's read this. What are these log hits that it's outputting? For semantic, reduce labels is used to make sure blah blah blah. Semantic segmentation task guide. TensorFlow, I don't want TensorFlow, I want PyTorch, so this one here. Can I resize this mask? And let's use the mask, apply mask to image. Return image. We don't really want this part here anymore, or do we? Yeah, I guess we do. Okay, close out of this. Let's get rid of these breakpoints. And let's run it. Go back here, refresh, thumbnail. Let's upload our cat pic here. Say animal, and we're gonna hit use Sam. That is just terrible. Absolute terribleness. Can we find a better image? Let's see an image from ImageNet. ImageNet 1K. Let's find a random ImageNet image and put it in there, see if we can get something. ImageNet 1K dataset. Pictures of cat. How about this image here? This one seems like a pretty save image as Felv save. Let's put this one in here. Animal, cat, animal. Okay, so we also kind of want the class names, right? We kind of want to know what the fuck it actually found. So let's do that. If it's not, we return none in class names. Okay, let's come back down here and we will make sure that it returns this, and then it also returns the gr segment out text box. And now we need to create this segment out text box. So let's do it here. So default here, let's do 6 lines or 4 lines. Found classes. And actually the gr segment out text box, it's not going to be a string. This is going to be a list. So we need to basically do this. We need to do comma dot join class names. So this will turn it into a list of, or a string. Let's rerun it. Refresh, go to thumbnail, upload this image, use SAM. So wall, tree, person, plant, let's put person in there. Holy shit, dude, this is so bad. What about grass? This just seems like noise. Let's save this for now. What do we add? We added torch vision and we got rid of this and put this here. The hugging face key, and we added this crap here. Maybe it's just because we're using the small model. Let's see if there's a bigger model here that we can use. So NVIDIA Segformer B0 fine-tuned ADE. Let's see if there's a bigger one. What about this one? Segformer B4. B2 cityscapes. Cityscapes are these like autonomous vehicle data sets. Ideally, we want something a little bit more. Like I'd take ImageNet over cityscapes. Let me filter by NVIDIA. Fine-tuned, 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 cityscapes, ADE, ADE, cityscapes. It looks like they only have cityscapes or ADE. Let's try this one here, this big one. Segformer B2 fine-tuned cityscapes 1024 by 1024. So hopefully this one's a little bit bigger and it'll maybe perform a little bit better. Let's put this here. Say model name. Model name. From pre-trained, let's get rid of these. And let's also rename this Let's call this processor, and let's run it. All right. Let's drag our cat image. Let's segment. Obviously, this is going to take a little bit longer. Roadside, vegetation, wall, person, car, truck. Let's see what happens when we put person. Road. These are so bad. Why is this so bad? Why is this segmentation model literally garbage? Hugging Face, this model is dog shit. Ugh. Can't have good things. This is why we can't have good things. Models. Image segmentation. Sort by most likes. Is this one any good? Facebook mask former Swin large. It's trained on the same data set, the 8020K. Monocular depth estimation. Face parsing. What about this one? Maybe this only works for like large external scenes. Let's actually download this image. I want to see if it actually even is working correctly at all. So let's put this image here. So this is literally from the data set. So ideally we should be able to segment out exactly what we want. Let's do building. What about sky? Okay, well finally we got like an okay looking mask there. But what about wall? God damn, if only the segment anything model was working, then we'd use that one, you know? Yeah, so I think if you do want to use the segment anything, you have to basically install it from source is basically what I'm learning here. So we're going to actually close out of this. Let's commit what we have something here. Let's let's rename these things just so they're a little bit cleaner. So let's do segment, and we're gonna call this segformer. Segment segformer, and then we'll have a different function for specifically the segment anything. So we're gonna leave this function as is, then we're gonna scroll down here. Right, to all the stuff that we added here. We're gonna say segment image to segment. Let's put this in an accordion with gr.accordion, and we're going to call this label equals, and we're going to call it segment with segformer. And we're going to put all of this inside that, just so it's like hidden, right? We don't necessarily want to see this. Let's call this segment segformer. And here, let's also do the with gr accordion. I'm going to say label remove background with replicate. And we're going to move these here. And let's see what this looks like. Oh. So now we have remove background with replicate, segment with segformer. Perfect. This is what we want. Let's also add here with the accordion, let's say open equals false. I don't think it's called open. What is it? It's called open false. Okay, it is called open. So remove background with replicate. Let's also make sure that that is on open equals false. And here in the thumbnail, let's add an accordion here as well. And put these bad boys in there. And we'll say generate foreground with OpenAI. And here, instead of combine, let's call this make thumbnail. Close out of that, run it again, refresh, refresh. And there we go. We have our three little separate things here with their little drop-down menus. Let's go ahead and save that, and let's push this. Let's push this to our GitHub. We're gonna say segformer. Segformer segmentation, which is actually pretty shit, so I don't know. Maybe it doesn't matter. Okay. Let's see. Is there any other cool image models in Hugging Face? Models. Image to image. Filter by most likes. SD ControlNet Open Pose. Anime background GAN. Seems kind of cool. What about this one? ControlNet Canny. ControlNet Open Pose. Stable diffusion image conditioned. What about this one? ControlNet Open Pose. Yeah, you have to install Stable Diffusion. Let's see. Let's sort by, yeah, I guess we just have to filter here by the ones. Keras IO, super resolution, deblurring, ControlNet HED. Ooh, look at this one, fast AI style transfer. Ooh, this model has one file that has been marked as unsafe. All right, let's not use that. Deblurring, ControlNet Scribble, ControlNet Pose. This is the one we just looked at. Let's see, depth estimation, object detection. Video classification, question answering, text to text generation, fill mask, zero shot classification, audio. We don't need any of these. I'm actually curious, what is the robotics models that they have on here? Grasp diffusion, deep RL grasping, B market. What the fuck is this? VC1 base and VC1 large. Vision transformer pre-trained on 4,000 hours of egocentric videos. Okay, it's kind of a random model to have. Image to text. This is the Salesforce Blip image captioning. We got good old clip model, which hasn't been updated in a while. Leon has a clip model as well. Ooh, there's a biomedical clip. It's kind of interesting. Fashion clip. So one thing that I also wanted to do is scrape images from archive PDF. Scrape figures from GitHub repo. The super scraper. Archive, scrape pictures from PDF, I guess. Maybe not scrape, maybe Python cut out pictures from PDF. How to extract images from PDF in Python. First, we would have to install, open the blank document. It's using fits dot. The fuck is fits? PyPy fits. Fits is a unknown workflow imaging. This looks very sketchy. 11 stars. I'm definitely not going to use that. That sounds like a bunch of viruses. Let's see. How can I extract all the images from a PDF file of a archive paper using Python? Let's see. Yeah, it also is recommending this fits library, but I'm a little sketched out. This one looks a little bit more trustworthy. You see you got some documentation. You can click here onto the home page, right? 2.4K stars. That seems a lot more reasonable. PyMu PDF. Let's see, let's install it. Pip install PyMu PDF. Let's put it in our requirements. In there. No. Do they have examples here? Is this the same thing? Yeah, it's the same thing. Okay, so let's import that. Go up to the top of our file import this bad boy. Import fits. We're gonna have to create a new function. We're gonna call it extract images. Why is this backwards? Let's do this. Let's put it somewhere down here. Get video, create Notion page, GPT text, GPT emoji, GPT image, resize BG. Let's go here. So extract images from PDF. We're going to have a PDF path. We're going to have an output folder. We don't really care about that. I think what we want is a list of images. Ensure the output folder exists. We don't really care about that. Open the PDF. This we do care about. Iterate through all the pages. That seems fine. Get the current page. That also seems fine. Get the images from the page. Image list equals PDF page.getImage. For image index, comma, image and enumerate image list. Sure. And let's actually put a little breakpoint right there. And let's make a grad.io little widget for this. So inside of our make thumbnail, so up here, let's do this. Let's say with GR accordion, extract images from PDF. Outputs. I feel like this is going to be an image gallery actually, but GR image. We'll just say that for now, GR PDF image. And we already have the archive link as a variable. Where is it? Input text box, right here. So it's going to be the GR input text box. Here, let's say we don't actually need this. Extract images button. Images button dot click calls extract images from PDF, and let's have no outputs for now. Okay, so if we save, run this. Go into our thing here. We should have a extract images from PDF. Let's click this button. Nothing happened. Extract images from PDF. Do that. And let's put a breakpoint. Let's paste in a PDF link. Do we have a PDF link? Well, we can come here to Papers with Code. Here we go, Audio GPT. Let's get the PDF link. Let's put that in there. And let's run this. Extract images. Okay. So the PDF path is this, archive.org. If we hit next, No such file. I think it needs to download this file. Download the PDF from the URL. Okay. So let's rename this to PDF URL. Put that there, and I think that should be better. So now it'll use the request library to download the PDF, and then it'll be able to extract from it. So let's go here, let's put in our PDF, let's go to thumbnail, let's hit the extract images. Now we're here. The PDF path is this local path now because we've downloaded this PDF. Let's hit next. Okay, it works. Let's hit next. How many pages does this have? 14. It loads an individual page. It gets the image list. The image list has length 0. Is there really 0 images in the first page? Yeah, 0 images in the first page. So it should just go there. Now into the second page. And now there should be one image here. It should be this one here, Audio GPT. Let's go in. What is the image? The image is in a weird format here. It's called an XREF. Okay, so you see this? This is like the image in the raw format here. See this? It's in bytes. So we need to convert the bytes into a PIL image. So you see here where it f.write image bytes. So let's extract that out. So kill that. Come down here. Come here. Say image bytes equals base image of image. And let's say convert image to PIL. Or actually, let's say NumPy image. We're going to need to import NumPy. It was just a matter of time before we finally had to import NumPy. Import NumPy as NP. And hit save. Let's also sort these imports. Oop, not that. Sort imports using rough. Rough is a linter that we've been using for this project. Come down here. Image. Close the PDF and then also list of images. List of images. Oh my god, it's so annoying that the auto format does that. Image lists or images dot append image, and then here return images, and let's make a gallery, image gallery, which is a grad.io abstraction. So extract images from PDF, and then let's add a gr extracted images gallery. Gallery of extracted images of RBG, and the output for our extract images button is going to be this gallery. Okay, let's see if this runs. So refresh, let's paste in our link. Let's go into our thumbnail. Let's extract images from PDF. Hit this extract images button. It's going to download the PDF, and then it's going to use the PyMD, whatever this thing was. We're going to hit play. We're going to hit play, play, play. It's going to extract all the images. It's a lot of images. Okay. It's loading them. Maybe it kills. Ooh. Ooh. All of these images are broken. Okay, so this extract image function here is not working. So these image bytes, let's copy paste this. Let's get ChatGPT to bail us out. The output of this function, of the function below, is being used to populate a grad.io image gallery. However, it seems like the image bytes are not being properly converted from the pdf.extract image to the NumPy arrays required by the image or by the gallery. Can you fix this function for me? Let's see what ChatGPT says. You're attempting to directly convert the image bytes to a NumPy array. However, you first need to decode the image bytes into a PIL image and then convert it into a NumPy array. Okay, perfect. So this is the two lines that we need right here. Actually, do I need to convert them to NumPy arrays, or can I just return a NumPy or a PIL image? I'm pretty sure I can just return a PIL image, and maybe grad.io knows how to deal with that. So let's kill that. Let's run it again. Let's copy. Refresh here. Refresh, paste the text. Go into our thumbnail, extract images from the PDF. It's downloading. Getting here. Let's hit play. Let's get rid of these breakpoints. And we should get all the images in a gallery. There we go. Look at that. All the images. That is very hard to read. Most of these are crap, too. Like, what is this? Oh, I think I know what's happening. These images aren't... Yeah, you see, these are all piece images. Oh, that is very unfortunate. It's not extracting, like these aren't even full images. Basically, these are all little individual pieces. You see that? I wonder if that's just specific to this PDF. Let's go back. Let's use a different PDF. Let's do this one. I think this one should be a full image. Texts. Put that in there. Extract images. Nope. This is the same problem, you see. It's all the little pieces. I wonder if ChatGPT knows how to do this. This code is extracting the images from the PDF, but they are but there are many little pieces of the images. Is there a way to extract the full images rather than the pieces? Oh my god, render the entire page as an image and use OCR to remove text from the images? That sounds terrible. That's so much extra work. Now we have like a separate OCR thing going on here. So here it converts the PDF into images, one for each page. Then it converts it to a grayscale in order to do OCR. You get the text mask, image no text, so it's somehow font. What is getting this? Composite of image gray. Okay, so here you see it's getting all the bounding boxes for the text, and then it's basically saying, okay, anything that is in text is going to be the image. You see how it creates this mask, And then once it gets everything that is in an image, it'll basically put all of that. That is a lot. I don't think I want to do that, because then not only are you not going to get the full image, but you're also going to get like, you're basically going to get this weird like tattered piece. I think the solution we had at the very beginning is actually probably the best, where you just upload the background and then you're good to go. Yeah, I also kind of don't like the separation here between texts, thumbnail, Notion, keys. I kind of want to get rid of this. I want to put all of these into on the same kind of thing. Right, I don't like that separation. So let's save this. Let's do a little bit of cleanup. Let's commit this. So to GitHub, we'll call this extract image from PDF. Trying to see if maybe this has a way to can you instead combine the images using the original fits code? Okay, so now it's trying a different strategy here. It's actually trying to combine the rectangles together. I actually kind of like this approach. Okay, let's use this. And we're also going to need the this function here, combined rectangles. Okay. Let's see if this works. If this works right off the bat, that's absolutely crazy. So refresh. Let's paste our image or our archive link. Let's extract the images. Pixmap has no attribute PNG. Let's give that to ChatGPT, see what it says. Let's try it again. Two bytes PNG. Page dot get image page rect for xref in image list. Too many values to unpack. Expected 2. So right here. So I think we need this, the not image list continue. Let's paste this error to ChatGPT. Is this what programming has become? I basically just sit here and paste things into ChatGPT and then it tells me what to do. Doesn't seem like I'm going to have a job for very long if that's the case, you know? Not that I have a job already, but... Stop. page has no attribute get image rect. What is going on here? Save me, ChatGPT. You're my only hope. Oh no, ChatGPT is trained on the older version of PyMu PDF, so the APIs are deprecated. That is a very good tip, Sheldon. I'm very glad you just gave me that. Let's give it one more try here. Yeah, so let's put a breakpoint here and actually see what the fuck is going on. All right. So, image list. You have a list of images. xref 0. I'm guessing these 4 numbers here are the rectangle. The first 4 numbers. Special variables, function variables, count, index. Image list of 0, page.getImageInfo. Oh, look at this, get image rects of image list 0. There you go. So actually there is a function already. So all you got to do is this. Page.getImageRects of image, or getImageRects of x 0 of x for x in image list. Let's see if this actually works here. Yeah, okay, that works. Let's see if these rect objects have intersects. Image rects 0.intersects. Nope. Image rects of 0 is a rect object. What does it have? It has ater base bin bool delete credit demo. Yeah, it doesn't have any of these functions here. The intersects or is adjacent. let's see. Here, this rect object. Let's go into the here and look for the definition of rect. So this should be a specific type of object here. Rect is infinite x with get image rex rect function. Recs support additional binary operations. Intersection. Here you go. Search for intersection. A and B must be a rectangle and B must be a rectangle. So if you do A and B, so here we go. If any rect and R, or rect, what about the adjacency here? I guess we don't need the is adjacent for R in group. Overlapping equals group and overlapping dot append. And the union delivers the smallest rectangle comparing both. So actually what you want is, here's the actual rect. Normalize is empty, top right, bottom quad, to rect, morph, round, include point, include rect, intersect. Wait, I guess it is there. What? Wait up. It's not intersects, it's just intersect. And then contains, transform, get item. I don't think I'm seeing an adjacent here. Null, contains, or intersects is also there. Okay. Actually, you know what? Let me just try it as is and see what we get. Let's close out of that. Let's rerun it. Thumbnail. Well, actually, first I need the PDF. Put the PDF in there. Extract the images. It's working. List object has no attribute intersects. Combine rectangles, receives rectangles for rect in rectangles. Let's go right there. Let's extract the images again. It'll breakpoint right here. Okay. So we got the breakpoint. Let's see what rect is here. Rect is a list of length 1. Okay, so we fucked up right here. And when we get the image rects for X in image list, we now need to do that. Let's rerun this. Rect is no longer a list of length 0 or 1, so we can keep going here. Let's get rid of this breakpoint, see what happens. Error. Rect has no attribute is adjacent. Let's get rid of this is adjacent here. I don't think we actually need that. Intersection should be fine. Let's close out of that. Let's rerun it. Let's paste the text. Let's go to thumbnail. Extract images. Error, rect has no attribute union. Util union rect. This is probably what we want. Let's see if there's any other use of the word union. Yeah, this is probably what we want. Util union rect, so this is going to be fits.util union rect of an empty rect and then the group for group in combined. And here is going to be fits.rect. Okay. Let's rerun that. Nope. Tuple object has no attribute as tuple. So this is line 574 right here. Rect.as tuple. Let's put a breakpoint here. Let's rerun it and see what happens. Okay. What does matrix of 2, 2 mean? These numbers do not look correct. There's 8 numbers here. The combined rectangles function is 41 long and each one has 4. But the numbers here are like bogus. This is literally maximum values. What is just image rects? So these look fine. Combined rectangles, these look legit. So something is happening in our combined rectangles. So here in our combined rectangles, if it's overlapping.append, overlapping, and then you util union rect of an empty rect and group for group and combined. Is there a union rect that is a little bit better here? R1 and R2. Let's do this. Can you improve this function? I think the union logic is incorrect. I don't exactly know what it's doing here. It's not exactly what I want. Let's put a breakpoint here. Let's see exactly what's going on. Okay, we're here. Combined is a list of rectangles. A list of rectangles. Inside each list of rectangles, you have an optional, so you can have one rectangle or you can have multiple rectangles. So if I just do fits util union rect like this, of combined, yeah, you see this is not, this function is garbage. What if I just do this? Intersect, transform, make rect, use sign. Where is that underscore fits dependency here? From dot import fit. So we go to fits. There should be an underscore fits here. If not, fits underscore fits. Get area. See if we search union here. Does it at least work if we have combined of one? Yeah, this one has two, so let's do this. Combined 1, 0, and then combined 1, 1. Okay, so combine rectangles combined. And you want to say for combined comms in combined if length of comms is equal to 1, continue, else new rect equals else for rect in combs rect equals combs of 0 for rect in combs 1 to the end. Rect equals fits dot util union rect of that. And then finally, let's call this combined single combined single Okay, so this is a little bit convoluted here, but it should be what we want. It's using this utility function, and it's out. Let's go into our data dir and delete some of this crap. There's a lot of crap in here right now. Okay. Put that in there. Extract images. Combined single. This needs to be like that. So you see here, the problem is that it's not returning a rectangle object. Yeah, you want a fits.rect of this. Yeah. How this is looking good. Rect object has no attribute as tuple. Let's put a breakpoint right here. Let's rerun this. You see, sometimes you get the actual rectangle, sometimes you get a list of size 0. So let's go back up here. This was correct here. Should be like that. Rect of as tuple. As tuple doesn't make any sense here. What does image crop take? Crop box. Left, upper, right, lower. So what is a rect? Rect has left, upper, right, lower. I think we can get rid of this and say switch from the rect coordinates, which should be x0, x1, y0, y1, x0, x1, y0, y1, to left, upper, right, lower. There we go. We're almost there, crossing the finish line here, getting close. All right, let's see it. Let's see it. Show me the money. Oh, no. Coordinate right is less than left. Okay. The crop rectangle as left, upper, right, lower. So what the fuck do those actually mean? Coordinate right is less than left. So x0, x1. This actually is correct. Should be like this. Left should be x0. Right should be x1. Upper should be y0. And lower should be that. Let's run it. Yes. Yes. These look terrible. These do not look like the correct crops. All right, so it's not getting the correct rectangles, which means it's not cropping the right thing, which means the gallery of images it's creating is not correct. So either the coordinates of these rectangles are not correct, or whenever you get this pixel map of the image page, maybe that isn't correct, right? Maybe the pixel coordinates here for this page image are different than the actual coordinates here. So why don't we put a little breakpoint here. Hit this extract images again. We'll hit that breakpoint. See what the page image is. So height of 1584, width of 1224. If we actually look at the image, what do we got here? We got height of 1584 and then width of 1224. So that kind of seems correct. What about our rectangles? So our combined rectangles, these all seem very small, right? Like all of these images or all of these rectangles are kind of constrained. What about the image rects up here? So I think maybe what's happening here is that we're only using the intersection. But if you remember in the original function that ChatGPT gave us, it also had adjacency. So if the images are even close to each other, it'll give you that as well. So one thing we could do, it's kind of a cheat code here, is basically say there's only going to be one image per the page. Let's assume that the lowest rectangle coordinate is the lowest point in the image, and then the highest rectangle coordinate is the highest point in the image. So what do we do this? Let's comment out this part here, the combine rectangles, and do this. Rectangle equals image rects of 0 for rect in image rects of 1. Move this up here. Let's move this up here. Let's put that there, and we'll comment out, well actually we'll just delete this. Absolute hogwash. All right, what are we at? We are at almost 3 hours here. I think we're going to stop it. I think I'm kind of stuck in a loop here. I'm not getting anywhere. This extraction isn't doing anything. So, stop this. Save what we have. We'll commit what we have. We'll go back, lick our runes, and then rejoin. So, attempt to combine rectangle images. Commit this, sync the changes. I'm going to go cry in a little corner until we figure out what is the correct way of doing this. Thanks for watching. I'll see if maybe tomorrow I do a something more interesting, maybe like a paper stream or something. But yeah, thank you for the tips. Thank you for watching, and see you guys later.